Welcome back, guys. This is question 3.24 of chapter 3, and here we have to find the probability distribution for the number of jazz CDs when 4 CDs are selected at random from a collection consisting of 5 jazz CDs, 2 classical CDs and 3 rock CDs. Okay, so the total number of the CDs we have to select are basically how much. So we have to select 4 CDs out of total how much. So the total number of CDs here are how much. So these are basically 5 jazz CDs, 5 2 classical CDs plus 2 and 3 rock CDs. Okay, so the total number of CDs we have are 10. Okay, so now in order to solve it, we can very clearly see that the selection of them is basically the total number of selections. So total selections are how much? Okay, so the total number of selections are, I have to select 4 CDs from 10, so therefore it will be 10 choose 4, so it will be the combinatorics. Okay, which is basically 10 factorial divided by 4 factorial and then 10 minus 4 factorial, which is the 6 factorial. So these are basically the total number of selections. Now I have to find the probability distribution and I have to express my answer by means of a formula. So what do I have to do here? In order to solve it, let us find the solution of it here. And here, in order to do so, first of all, what will I have to do here? I have the 5 jazz CDs, and here to find the probability of selecting X number of CDs would be how much. So here, first of all, from 5 jazz CDs, I have to select any number of CDs which are X. So from the 5 jazz CDs, I have to select the X number of CDs. Okay, so when these X are selected, how many are left? The left CDs I have to select would be 4 minus X. Okay, so X are selected, so out of 4, how much are left? I have to select here. Okay, so now here from these I have the CDs which are left behind are 10 minus 5. Okay, so which are those 5? Those are 2 classical and 3 rock CDs. So here again I have 5 number of CDs, or I can also write it like, okay, let me simplified by writing it the 2 classical CDs and 3 rock CDs, which will ultimately give me how much? Which will ultimately give me 5. Okay, so these are the number of CDs I have to select and divided by the total number of selections which I have already found out, and these are given here. Okay, so now let me write them here, and it will be 10 choose 4. Okay, so now these are basically the probability of different items I have to select. In order to find the number of CDs from the jazz which are 0, what I have to write here? I have to write here X equal to 0, putting X equal to 0 here, and I will get the answer, and so on. So therefore the value of X will range from 0, 1, 2, 3 and most up to 4. Okay, these are the total number of the items which I can select here, and this is the formula I can use to find out the probability distribution for the set question which we were asked to find by means of a formula. Okay, so this thing is already given here. Okay, so that's it for today, in which we have found out the probability distribution formula for the problem at hand. If you have any question, you can ask me in the comment box, and also you can simplify this one to find out different probability distributions and so on. So that's it for today, and see you soon. Hello guys, I hope all of you will be fine. So this is question 3.25 of chapter 3, and the statement of it is, from a box containing 4 dimes and 2 nickels, 3 coins are selected at random without replacement. Okay, so find the probability distribution for the total T of the 3 coins, or the total number of cents in 3 coins. Okay, so express the probability distribution graphically as a probability histogram. Okay, so the amount of the given data which is given here, so let me put it here, and that is, let me have this given data and let me represent this dimes with D and nickels with N. Okay, from the given data it is said that there are 4 dimes. Okay, and how many nickels? We have 2 nickels. Okay, so from the cost of the dimes we know that 1 dime is equal to the 10 cents. Okay, and 1 nickel is equal to how many cents? These are basically 5 cents. This is already given. Okay, so from them, if we have this total number of coins which are 6, we have to select any 3 coins. Okay, so we have to select how many coins? 3 coins without replacement. What is mean by without replacement? Once a coin has been selected, it will not put back into the original number of coins. Okay, so this is the without replacement. So now what do we have to do? We have to find the distribution for the total of the 3 coins. Okay, so now let me solve it, and in solving it let me have here the solution. So what are the combinations we can have here? So suppose initially we have the 3 coins which are dimes, so we can have here dime, dime, dime of the 3 coins. Okay, similarly we can also have 1 nickel out of the 3 coins, so it can either be dime, dime, nickel, or dime, nickel, dime, or nickel, dime, dime. Okay, we can see here that these 3 are basically lie in the same category in which we have only 1 nickel. Okay, so therefore we will have a single term for it. Okay, so here this is a separate, this one is separate. Okay, similarly for the 2 nickels, what can I have here? Either here I will have nickel, nickel, dime, or nickel, dime, nickel, or dime, nickel, nickel. Okay, so here these 3 are also in the same category where we have 2 nickels, and we cannot have here more than 2 nickels because the given number of nickels here are 2. Okay, so therefore the cost here would be how much? The cost here of this one, or the total cost here would be for this one will be how much? This will be 10 plus 10 plus 10, this will be 30 cents. Okay, for it will be 10, 10, 5, or 10, 5, 10, or 5, 10, 10. So these 3 will give me the equal number of cents. It will be 25. And similarly for this one, here I will have 5, 5, 10, or 5, 10, 5, or for dime 10, nickel 5, nickel 5, here it will be 20. Okay, so for each of them it will be the same for each category, for the each number of the dimes or the nickels. Okay, so now what do we have to find out here? We have to express the probability distribution graphically as a probability histogram. For what? For the probability distribution of the total T. Okay, so now here in order to find it out, for let me have here the probability that T is equal to 20. Let me start it from 20, and here in this range we can very clearly see that this is the range, and here we can clearly see that we have 2 nickels and 1 dime. So these 2 nickels have been selected out of these 2 nickels which are in total in number. So therefore it will be what? It will be the 2 out of 2 choices 2. Okay, similarly we have only 1 dime here, which is here, and this 1 dime has been selected from the total number of dimes which are 4 here. So 4 choose 1. These are the number of choices we will have here, dividing it over the total number of choices. Okay, so the total number of choices here will be the 3 out of this 4 plus 2, which is 6. So therefore it will be the 3 from what? 4 plus 2. Okay, so this 4 plus 2 is basically how much? This 4 plus 2 is 6. Okay, so you got my point that here in the numerator what I have to write, I have to write the choices in event divided by the total number of choices. Okay, so total number of choices. So there, that's what I have done. So now simplifying it, what I will get, 2 choice 2 is 2 factorial divided by 2 factorial, and then 2 minus 2 is 0 factorial, multiply it with the 4 1. So 4 factorial divided by 4 minus 1, 3 factorial, and this 1 factorial. Okay, and also dividing it over this one, 6 factorial divided by the 3 factorial, and then 6 minus 3 is also 3 factorial. Okay, so solving it out, what I will get here, the answer of it would be how much? That is 1 over 5. Okay, similarly for the probability that t is equal to 25, which is basically this one, and here we can see that we have 2 dimes, okay, here and 1 nickel. Okay, so in order to do so, what can I write here? Here I can see that the total number of choices will remain the same, which are 6, choose 3, while here for the nickel I have only 1 nickel out of the total number of nickels, which are 2. Okay, so 2, choose 1, while the dimes here are 2. Okay, so I have to select these 2 dimes, any number of dimes from the 4, total 4. Okay, so now solving it by using the same formulation, what we have done here, I will get here 3 by 5. Okay, you can try it out. Similarly, let me move down somehow, and here for the probability that t is 30, what I have to do here, I can see that when t is 30, I have 3 dimes, okay, and no nickel. So therefore, for the nickel, I have 2 nickels. For them, I have 0 nickel here, while for the dimes, I have total number of dimes 4. From it, I have to choose 3, while the total number of choices will remain the same, which are 6, 3. Okay, so here from it, what I will get here, it will be 1 by 5. Okay, so these are all the probabilities whatsoever we have found out here. Okay, so here we can also write them out here. So let me write them out here. This is what we have, this is t, and this is the probability of t. Okay, so now writing them out here, the t is 20, 25 and 30. Okay, and the probabilities we have them for here the probability of t equal to 20 is 1 by 5. For 25 I have 3 by 5. For 30 I have also 1 by 5. Okay, so therefore these are the probability distribution, because by adding 1 by 5, 3 by 5, 1 by 5, what I will get, the summation of them all will be equal to 1. So this is the probability distribution. So let me also draw it here as well. So in order to draw it, let me have this one. This is what we have. So this is what the random variable t, this is what we have, the probability of t. Okay, and also we have some values here. Let me have here 0, this is, let me have 20, this is 25, and this is 30. Okay, and let me have different values here. Let me have here, this is 1 by 5, this is 2 by 5, and let me have this one as 3 by 5. Okay, so let me draw them here, and the first one, which is 20, p of t for it is 1 by 5. This will be for it, and this is for p equal to 20, this is 1 by 5. Okay, similarly for the 25, here we have 3 by 5. So this is here, and let me start it from here and have to move here, and it will be like this one. Okay, so this is what This is the 3 by 5, the histogram for t equal to 25. Okay. Similarly, for 30, I have here this one, and this is 1 by 5. So for 1 by 5, I have here this one, and this is the distribution for it as well. We can also make it more convenient by reducing the size of the boxes as well. If you reduce the size of the boxes, just like here, let me make it more convenient by reducing the size of the boxes as well, and you can see that the plot here will be more beautifully look like. So it is 20, it is 25, and it is 30. Okay, and here it will be like this is here, and also this is here, and this one here as well. Okay, so here this one is 3 by 5. Okay, this one is 1 by 5. Okay, so these are what, these are the probability distributions. Both are the same, but here the width of the bar is somehow lower as compared to this one. Okay, so that's it for today, in which we have seen that how to calculate the probability distribution function for the random variables which we have been given here. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.26, and the statement of it is, from a box containing 4 black balls and 2 green balls. Okay, so we have a box in which we have 4 black balls and 2 green balls. 3 balls are drawn in succession, each ball being replaced in the box before the next draw is made. So this is basically the sampling with replacement. Okay, find the probability distribution for the number of green balls. Okay, so here we have, let me have here the given data, and in given data let me have here this box. Okay, and in this box we have 4 black balls, which are 1, 2, 3, and 4. 4 black balls and 2 green balls. Okay, so these are 1 and 2. Okay, so these, out of these balls, what do we have to do? We have to select, let me use another color for it, which is this one. We have to select 3 balls, okay, which are selected randomly, and another statement has been given here, and that is the with replacement. Okay, so what is mean by with replacement? Once a ball has been selected, it will be put back into the same bucket, and in next turn the same number of balls will be present in this box. Okay, so this is the with replacement. If I will select a ball out of it and will not put back it into this bucket, that would be the sampling without replacement. Okay, so here I have been doing all the sampling with replacement, and here the probability of the ball equal to black, or probability of black ball, how much is this? We have here the total number of black balls 4 divided by the total number of balls, which are 6. So here the probability of black balls are basically 2 by 3, and similarly the probability of the green balls is how much? That is number of green balls divided by the total number of balls. So here it would be 1 by 3. Okay, so this is what, this is the probability of different balls. Okay, so now we have these balls, and let me remove it and start solving it here. So the solution of it would be here, and in solving it, what do I have to do? I will have different sampling arrangements or combinations for them, and these are the sampling combinations. Let me write them here. So samples. Okay, on the basis of it, what will I have? I have to find the number of green balls and their probability distribution. So it will be the number of green balls, and or ng, or it can also be represented at x, and also the probability of the x of that event. Okay, so let me write them here, and here it will be like this one. Okay, so the first sample here I can have would be the black, black, black. Okay, so for it the number of green balls are 0, so therefore the probability of it, as these are the three independent events, so what it will be, it will be 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3, so it will be 2 to 4, 4 to 8, so 8 divided by 27. Okay, so the probability of this is 27. Similarly, for the next I can also have black, black, and then green. Okay, so for it the number of green balls are 1, and what will be the probability of it, it will be 2 by 3 multiplied by 2 by 3 for the black, and for the last one which is green the probability of it is 1 by 3, so it will be how much, it will be 2 to 4, 4 divided by 27. Okay, so similarly for the green ball here as well, for the third I can have black, green, and the last one here is black. Okay, so here the number of green balls is again 1, and after you will calculate it, here you will have 2 by 3 multiplied by 1 by 3 multiplied by 2 by 3, it will be the same which is for here as well, so it will be 4 divided by 27. Okay, similarly for the last one here in this combination I will have here what, I will have here one black and two greens, green and green. Okay, so now the number of green balls are 2, and here by finding them out, what I will have here, I will have 2 by 3 multiplied by probability of green which is 1 by 3, and the last one here is 1 by 3, and here we will have 2 divided by 27. Okay, so these are for these 4. Similarly for the next turn I will have green and then 2 black. Okay, so again we can see here that we have one green, so here it will remain the same, and the probability of one will remain the same here, and that is 4 by 27. Okay, by multiplying them together the probabilities you can find it out. Similarly for the next item you will have here green and here black, and the last one here would be green as well, and here you can very clearly see that we have two greens, and therefore the probability of it is 2 by 27. Okay, and for the here we will have green, green, and the last one here is black, and the number of greens are 2, and the probability of it is 2 by 27. Okay, so this is what for it we have. If we had the 3 balls here, or in this combination we can also have the third green ball here as well, because this is the sampling with replacement, so therefore here we can also have here green, green, green in the 3 turns as well. So here the number of green balls will be 3, and here multiplying them together the probabilities which are 1 by 3 multiplied by 1 by 3 multiplied by 1 by 3, so it will be 1 by 27. Okay, so these are all the probabilities whatsoever we have here. Okay, so now writing the different probabilities of the different balls, what we can have here. So let me write here the probability of x equal to 0, or the number of green balls equal to 0. So the probability of it is already given, and that is only a single item which is here. Okay, so this is only the single item, and for it the probability is 8 by 27. Okay, so this is 8 divided by 27. Okay, similarly for the probability that x is equal to 1. Okay, so let me move down somehow. So here what will it be, we will have to see that what are the events where x is equal to 1. So here I have this and this. These are the three events in which these are 1. So I have to add them together. So 4 by 27, the first one, plus 4 by 27 for the second, and 4 by 27 for the third one. Okay, or multiplying them with 3 with the single item. So what will I get here? I will have 12 divided by 27. Okay, for the probability that x equal to 2, what I will have here, all the items where the x equal to 2. So here this one and this, and for them all I have 3 multiplied by 2 by 27. Okay, so what will I have here? It will be 6 divided by 27. Okay, and for the last one where the x equal to 3, okay, or the probability that x equal to 3, what is the probability of it? This is already given, and that is 1 by 27. Okay, so that's it, what we have for different items of the number of the green balls. Or now plotting it out here, what I will have, this is x, this is p of x. Okay, and here we will have these items, like this is 0, 1, 2, 3. Okay, so we will have them here. Okay, let me put them here. It will be 8 by 27 for the 0. For 1 I will have 12 by 27. For 2 I have 6 by 27, and for 3 I have 1 by 27. Okay, so by adding them all, when you will add them all, you can very clearly see that it will give me output equal to 1, which is the basic condition for the probability distribution, that when you will add all the probabilities, it must give you the answer equal to 1. Okay, so that's it for today, in which we have seen the probability distribution for the question 3.26, in which we have found out the probability distribution for the number of item selection with replacements. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.27. And the statement of it is, the time to failure in hours of an important piece of electronic equipment used in a manufactured DVD player has the density function which is given here. Okay, that is f of x, and which is 1 by 2000 exponential of minus x divided by 2000 for x greater or equal to 0, and it is 0 for x less than 0. Okay, so on the basis of it, we are given some parts. So let us start the solution of the part A of it, and in solving it, what we have to do, let us solve it here. Let me first write that what is the density function what we have. So that is f of x equal to 1 over 2000 exponential of what, minus x divided by 2000. Okay, so that is what the density function we have. In order to find the CDF of it, or capital F of x, what do we have to do? We have to integrate this function from 0 to any unknown value, that is, let me call it x. Okay, so let me write it here, and from 0 to x, because it is starting from 0, so let me take it from 0 to x, and here writing the density function in another domain, and let me choose that domain as small t. Okay, so it would be exponential of minus t divided by 2000 and integrated with respect to t. Okay, so now integrating it, what I will get here, it will be 1 over 2000 outside of this integrals, and here 0 to x exponential of minus t divided by 2000. Okay, and d of t. Okay, from the previous section we have seen that the integration of the exponential is what, if I have a exponential of ax. Okay, so the integral of it with respect to x would be how much? So it would be the exponential of ax. Okay, so let me apply the same over here, and what I will get here, this f of x would be what? It would be this negative sign here, so it will become minus exponential of minus t divided by 2000. Okay, and the range it has 8 from 0 to x. Okay, so let me write these ranges here, and in writing these ranges here, it will be minus, and here it will be the higher range here will be the exponential of x divided by 2000. Okay, and subtracting for it exponential of 0 divided by 2000. Okay, so these are basically the ranges whatsoever we have. Okay, now simplifying it on the basis of these ranges, what I will get here, we will get what? Exponential of 0 is 1. Okay, and it will be what? Exponential of, sorry, here we have minus x. Okay, so here we have the minus x. Okay, so here what we will have, this minus 1 become plus 1 because this negative will be multiplied with all of them, and it will become what? It will become 1 minus exponential of what? Minus x divided by 2000. Okay, and that is what? That is the value of f of x for all x greater or equal to 0. Okay, and similarly it will be 0 for all x less than 0, and this is what? This is the solution what we wanted to find out here. Okay, so that is what? The solution of part A. Okay, so similarly on the basis of it, what I have to find out in part B, we are asked that determine the probability that the component and thus the DVD player lasts more than 1000 hours before the component needs to be replaced. Okay, so here what do I have to find out? I have to find out the probability that the component lasts more than 1000 hours. So if the hours here are capital X, so it should last more than 1000 hours. Okay, so in order to find it out, going beyond 1000 is what we have to subtract all the values lower than 1000 in the CDF. So it will become 1 minus f of 1000. Okay, so I hope you have got this point, and on the, let me also explain it here as well. So if I have the CDF plot here, let me have the CDF plot, and it is like this one. Let me have some values here, and if I want to find out the value, if this is, let me call it 1000. Okay, and if I want to find out the values which are here in this range. Okay, and I know that here ultimately it will converge to what? It will converge to 1. Okay, so what will happen? I have to subtract this overall or this area, which, or we can see that all this area which is the overall here is 1. So I have to remove this area from it, so therefore I have to subtract this one from 1. Okay, so this will be this f 1000, which are basically the lower accumulated values. So therefore I have been doing it, and these would be the higher values what has been given here in this blue color, and which is here this one. Okay, so I hope you have got my point. Okay, so now let me remove it and let me solve it here as well. Okay, so let me write these values here, and it will become 1 minus the exponential value here is 1 minus exponential of minus 1000 divided by 2000. Okay, which is the value given here. Okay, now let me find them out, and finding them out I can very easily see that it will become 1 minus 1 plus exponential of, this will be minus 1000 by 2000, this will be minus 0.5. Okay, these two will cancel out, and ultimately we will have exponential of minus 0.5, and the answer of it would be 0.6065. Okay, that is what, that is the answer of part B, and for it I have used the formula which is given here, and I have also explained it on the basis of the graphical illustration. Okay, the last part of it is determine the probability that the component fails before 2000 hours. Okay, means will reach it will not reach the 2000 hours, or it will be malfunctioned before these 2000 hours. So let me move down somehow. Okay, so here let me solve this question here, and it will be, I have to find out the probability that the hours are less than, sorry, yes, 2000. Okay, so in order to find it out, I can very clearly see that in CDF all the previous up to 2000 has been accumulated. So therefore I have to find f of 2000. Okay, so I hope you have got this point, because when this one is like this one, okay, and it is like, let me have here this 2000. So finding the probability here means all the values has been accumulated here, because this is the accumulation. CDF is basically the accumulation which is represented by f of x, and this accumulation is the accumulation of the probability distribution. Okay, so now putting this 2000 here, what I will get? I will get 1 minus exponential of minus 2000 divided by 2000. Okay, so here it will be 1 minus exponential of minus 1, and ultimately it will give me what? It will give me 0.6321, and that is the solution of part C of my question. Okay, so that's it for today, in which we have seen the three parts related to the CDF and the probability density function. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.28 of chapter 3, and the statement of it is, a cereal manufacturer is aware that the weight of the product in the box varies slightly from box to box. In fact, considerable historical data have allowed the determination of the density function that describes the probability structure for the weight in ounces. Letting x be the random variable weight in ounces, the density function can be described as this function, which is f of x, and this is 2 by 5 in the range which is given here, in which x is greater or equal to 23.75 and less than or equal to 26.25 and 0 elsewhere. Okay, so in given data we can see that this is basically the f of x, this is x, this is f of x, and it only lies between 23.75, let me say this is 23.75 up to 26.25, 26.25, and the value of it is 2 by 5. Okay, so let me have here, this is 2 by 5, and it is constant in between these ranges. Okay, we can see that this is the area under 23.75 and 26.25, which is 2 by 5. Okay, the value of it is 2 by 5, and we have to find different answers given in the form of question A, B, C. Okay, so what is part A? We have to verify that this is a valid density function. Okay, so in order to verify that it is a valid density function, what do we have to do here? The area in between this, or the overall area here, should be equal to 1, which is the cumulation of all the probabilities lies in between these ranges. Okay, so as we can see that this is a continuous random variable, so therefore in order to find the area, what we can do, we can use here this function which is the integration. Okay. So in order to integrate this of x, what do we have to do? We have to write different ranges which are from 23.75 up to 26.25, and here we have to integrate our function f of x d of x, and we have to see that what is the area in between here. Okay, if the area is equal to 1, then this would be a valid density function. Okay, so what is f of x here? So let me write the value of f of x here, and that f of x is given, and that is 2 by 5, and here this is d of x. Okay, so now in order to integrate it, what we can see that here we have this 2 by 5 which is a constant, this is 2 by 5, and here it would be these two ranges 23.75 and 26.25. so 23.75 and 26.25, and this is this, and here from it I will get what? This will be 2 by 5 multiplied by x, and this will be the range from 23.75, and the higher range is 26.25. okay, so now let me write these ranges here, and here we will get 2 by 5, and the ranges of x will be from 26.25 minus 23.75. okay, subtracting for it, what I will get here? I will get 26.25 minus this, so I will get here 2 by 5 multiplied by 2.5. okay, so 2.5 here, so let me calculate it. It will be 2.5 multiplied by 2 will be 5 divided by 5, which is what? Which is equal to 1, which basically shows me that this one, okay, this one is a valid density function, and that is because of this one, which is the area in between these two ranges. okay, so that is the area which is covered by this curve. okay, so that is what the answer of part A is. Now in order to solve part B, let me first see that what is it. Determine the probability that the weight is smaller than 24 ounces. So the weight is smaller than 24 ounces, we have to find the probability of it. So we can see that this range, the smaller range is 23.75, and up to the higher range which is 24, we have to find the probability here, and that probability that x is what? X is less than 24. okay, so here in order to do so, we have to write the lower range, because below this the probability is 0. so therefore this would be 23.75, and here it will be 26 point, sorry, it will be the higher range here will be 24, because the higher range is this one, so I have to write this one. And here, as we have previously seen, that it would be 2 by 5, here it would be d of x. okay, so now writing it, it will be 2 by 5, and here x, and 23.75, and here I will have what? 24. okay, so now then calculating it and then finding all, we will see that here the answer of it will be 0.1, which is the probability that the weight is less than 24. okay, so that is what the answer of part B. okay, so let me move down somehow and see that what is the part C. So in part C, we have to see that the company desires that the weight exceeding 26 ounces be an extremely rare occurrence. What is the probability that this rare occurrence does actually occur? okay, so what we have to do in this case, the lower range is 26, and higher than this would be 26.25, and exceeding from 26 up to 26.25 is a very rare case. okay, we have to find the probability of it. So it would be what? This is part C, and we have to find the probability that the weight is greater than 26. okay, so this would be what? This would be the lower range. Let me have it here 2 by 5, again the same function, and the lower range here would be 26, and the higher range here will be 26.25. okay, and here we will have this d of x. Okay, now again calculating it and finding all the probabilities, let me write here, this would be 2 by 5, okay, and multiplying it with the value which we will get here, that would be x. So from it I will get 26.25. So here we will get 0.25, and finding it out we will get 0.1, which is a very rare case because of the probability we have here. Okay, so this is the probability that x will be greater than 26, or the weight will be greater than 26 ounces. Okay, so that's it for today, in which we have seen the solution of question 3.28. If you have any question, you can ask me in the comment box. Welcome back, guys. I hope all of you will be fine. So this is question 3.29 of chapter 3, and the statement of it is, an important factor in solid fuel is the particle size distribution. Significant problems occur if the particle sizes are too large. From production data in the past, it has been determined that the particle size in micrometers distribution is characterized by this f of x, which is 3x raised to the power minus 4 for x greater than 1 and 0 elsewhere. Okay, so what do we have to find out on the basis of all these data? We have three options, A, B and C, and we have to find the answer of each of them. Okay, so in first part of this question, we have to verify that this is a valid density function. Okay, so let me start the solution of it. So in solving it, let me have, this is part A, and in order to verify it, what do we have to do? We have to see that whether in this range, which is x greater than 1, whether this function converges to 1 or not. Okay, if this function, which is here in this one, if it converges to 1, then it would be a valid distribution or valid density function. Okay, so let me start it now here, and here in order to do so, we have this function and I want to integrate it within this range. So it is starting from 1 because x is greater than 1, so it is starting from 1 because this is a continuous function, and will end at infinity because x is greater than 1, it goes to infinity as well. Okay, now at the end of it, I have to write x dx, which is what I have to integrate it. Now let me put their values, and here putting their values, what I will get, it will be 1 infinity, and the value of f of x is 3x minus 4 dx. Okay, so now let me solve it. 3 is the constant, so it will come out of this integration. So now 1 infinity x of minus 4 dx. Okay, so now integrating it, what I will get here, I will get 3 multiplied by x minus 4 plus 1 is minus 3 divided by minus 3, and it is from 1 to infinity. Okay, these two will cancel out, and here we will get minus x minus 3, and here 1 infinity. Okay, let me put their values, the ranges we have here. So putting these ranges here, what I will get here, x of minus 3 or 1 over x of 3, so it will become infinity cube, and similarly from it I have to subtract this 1. So putting the value of 1 here as well, what I will get, 1 over 1 of 3. Okay, why is it? Because here this x of minus 3 can also be written of x cube. Okay, so it can also be written here like this one. So now solving it, what I will get, this 1 over infinity is 0, and this 1 over 1 is 1. So ultimately from here I will get 1, which means that this is a valid density function, and from it we have found out that this one is equal to 1. Okay, so now similarly going to part B of it. So part B here, and we have to evaluate f of x, or what, we have to evaluate the CDF from it. So it will be f of x, and here I have to integrate it from the limit or the lower limit to any other point. Let me take it as x, okay, and for it I have to change the domain of my function, and here I am changing it from x to t, and what I will get here, I will get t minus 4 and dt, okay. From here what I will get, going through the same process whatsoever we have done here, I will get here minus t of minus 3, and here I will have 1 and x, okay, and going through all these processes and putting these ranges here, what I will get here, I will get x minus 3, and then here putting 1, I will get here 1, or ultimately 1 minus x of minus cube, okay. This is what we have here, and that is what, that is for x greater or equal to 1, okay. So that is what the solution of part B, okay. And here we can also see that what about the ranges which are less than 1. So for x less than 1, it will be what, it will be 0, okay. So that is also another range here we have. So let me also put it here as well, and this is for what, this is for this f of x, okay. So I have found out the value of CDF from it as well, okay. So in order to solve part C of it, let me move down somehow, and here I have to find out that what is the probability that a random particle from the manufactured fuel exceeds 4 micrometers, okay. In order to do so, what I have to find out, I have to find out that the probability that x is greater than 4, okay. What can, how can I find it out? I can basically find it out from f1 minus f of 4, okay. And the reason I have told you before it, and that is because of, let me have here this f of x, okay, and here we have x, and here we can see that here, if this, these are the densities, okay, and if I want to find out, let me have here the area, here we have 4, and all these areas, these are what, these are greater than 4, okay. And all of these areas which are, let me use here this yellow color, okay, all of these areas are what, these are all less than 4, okay. So here we can see that this is the area what we want to find out. So here all these will give me 1, okay, because this will converge here to 1, and in order to find from it this area, what we can do here, here this is the accumulated probability function. So therefore from 1 I can subtract this area and I will get the whole one which is here, okay. So that's why I have used this one here, okay. You can see that why I have used here, because this 4 is what, this is the area here, and this one is the total area here, and I want to find out here this one, okay. So from this function I can easily find it out. So let me put their values. So here it will be 1 minus this f of 4 which is greater than 1 here. So let me put their values here, and it will be 1 minus the value of x is now 4 minus 3, okay. So now opening it, what I will get, 1 minus 1 plus 4 minus 3, these two will cancel out, and here I will get 4 minus 3 or 143, so it will be 1 over 64, okay. So that is what, that is the solution of part C what we wanted to find out, okay. So that's it for today, and the essence of these type of question is not to go through all the questions again and again, but to let you know that what is the essence of the questions like this one, how can you use the probability density function, the cumulative distribution function, and all these things to find out the essence of the real world problems. Okay, so I think it's enough for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.30, and today we are going to discuss it in the context of the random variables and probability distributions. Okay, so the statement of it is, measurements of scientific systems are always subject to variation, some more than others. There are many structures for measurement error, and statisticians spend a great deal of time modeling these errors. Suppose the measurement error x of a certain physical quantity is decided by the density function, which is given here as f of x, which lies in between -1 and 1, okay, and 0 otherwise. So what are the options we have here? In part A of it, we have to determine k that renders f of x a valid density function. Okay, so in order to do so, let me solve it here. Okay, and this is part A. So in order to describe any density function and make it as a valid density function, what do we have to do? All these probability densities should be accumulated to give us 1. Okay, so what do we have to do here? I have to take the limits which are from -1 to 1. In this limit, I have to take this f of x dx, and it must be accumulated and give me 1, which is basically the condition for a valid density function. Okay, so let me put values here which are the values of f of x. So here this would be -1 1, and here it would be k 3 minus x square, and it should give me 1. Okay, so now in order to do so, this k is constant. Similarly here, now I will have -1 1 3 dx. Okay, this should always be equal to dx here as well. Okay, here also we must have minus and -1 to 1 x square dx. Okay, and it must give me 1. Okay, now let me simplify it, and simplifying it, what I will get here, I will get 3x and -1 1, and also here minus, and here I will get what, x cube divided by 3, because the exponent of it will be summed by 1 and the same will be divided with it over it, and here -1 1, and it should be 1. Okay, now putting the values of these limits, what I will get, let me put these values, and here I will get 3 and 1 minus 1, so here I will get 3 1 plus 1, and here -1 by 3, and here what, here I will get 1 plus 1. Okay, and it must be equal to 1. Let me do it again here, and it will be 3 to 6. Okay, and minus what it will be, it will be 2 by 3. Okay, so it will be 2 by 3, and it must be equal to 1. Let me simplify it further, and it will be 18 minus 2 is 16, so 16 divided by 3, and this is equal to 1, and ultimately it will give me the value of k, which is 3 by 16, and that is the answer of part A of my question, that the value of k is 3 by 16. Okay, so we have done part A of our question. In part B of it, we have to find the probability that a random error in measurement is less than 1 by 2. Okay, so to do so, what do we have to do here? In order to find it out, first of all, we have to find the CDF of it. Okay, so in order to do so, in order to find the CDF of it, what I have to do, I have to take this f of x, I have to find it out, and here I have to take the values from the lower up to certain value, which is x. Okay, and I have to change the domain of my function here as well, and in order to do so, I will change it from x to t. Okay, so the value of k is already known, that is 3 by 16. So 3 by 16, and the other values are 3 minus t square and integrated with respect to t. Okay, so here we have it, and integrating it, what I will get, let me try it here as well. So it will be 3 by 16, and here separately integrating each one, here this will be minus 1x 3 dx, sorry, dt, and here minus 1 to x, and here t square dt, and here we have it. Okay, so now let me simplify them. I will get here 3 by 16, and here I will have 3t minus 1 to x and minus t cube by 3, and here minus 1 x. Okay, so simplifying it, and at the end what I will get here, I will get 3 by 16 3 x plus 1. Okay, because x and minus 1 will be plus 1, and similarly here minus 1 by 3, and here this will be x cube, and minus this will be plus 1. Okay, so ultimately what I will get here, ultimately the answer of it will be what, it will be 1 by 16. Okay, and here it will be minus x cube plus 9x and minus 8. Okay, that is what, that is f of x, and that is basically the cumulative function which I had to find out here. Okay, so in order to find the probability that a random error in measurement is less than 1 by 2, what do we have to do here? I have to find the probability that the random error x is less than 1 by 2, and this is what, this is the f 1 by 2. Okay, so let me put their values here in this f of x. What I will get, it will be 1 by 16 and minus 1 by 2 cube, okay, plus 9, 1 by 2 and minus 8. Okay, so here we have it, and ultimately the answer of it, what I will get is 99 divided by 128. This is the answer of part B of my question. Okay, so you have seen that I have found out f of x, and on the basis of it I have found the answer of it. Now part C of my question is, for this particular measurement it is undesirable if the magnitude of the error x, absolute value of x, exceeds 0.8. What is the probability that this occurs, that x exceeds 0.8? So what do we have to do here? I have to find, this is part C of my question, and here I have to find the probability that x absolute exceeds 0.8. Okay, so this exceed is basically what, this is basically the probability that x is less than minus 0.8, okay, or the probability that x is greater than 0.8. I have to encounter both of these cases, and then accumulating it will give me the answer which is required here. So in order to find it out which is less than this one, I can write here very easily by using the CDF, and it will be minus 0.8, while for this one I have to see that this one is what, this is the greater one, so I can find it out by probability of x less than 0.8. Okay, so let me put their values here. So it will be what, 1 plus 1 minus f of 0.8. Okay, now putting these values into what, taking it and then putting the value 0 minus 0.8 here, and then taking this one and putting 0.8 here, what I will get, ultimately the answer of it will be 0.164, and that is what, that is the solution of part C of my question. Okay, so that's it for today, in which we have seen the solution of question 3.30. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.31 of chapter 3. Based on extensive testing, it is determined by the manufacturer of a washing machine that the time y in years, okay, so in years the time has been represented as y, before a major repair is required, is characterized by the probability density function, which is given by f of y, and that is 1 by 4 exponential of minus y by 4 for all the values of y which are greater or equal to 0 and 0 elsewhere. Okay, so what do I have to find out? On the basis of this probability density function, I have to find out the answer of two parts, and the first part of it is a. Critics would certainly consider the product a bargain if it is unlikely to require a major repair before the 6th year. Comment on this by determining probability of y greater than 6. Okay, so what do I have to find out? I have to find out the probability that a major repair will also be required after the 6th year, because during this time it will need a major bargaining. Okay, so therefore what I have to do, let me write here the solution. Okay, and in solving it, what do I have to do? I have to find out the probability that y is greater than 6, and now let me find the f of y, which is the CDF for this one, because this is now the PDF and its CDF would be f of y. Okay, so now in order to do so, let me find it out, and here in order to find it out, we have to find the CDF for it for all the values greater than 0, and for that let me use the same function here. Here I am already writing the constant outside of my integral, and here writing it from the lower value up to some arbitrary value, let me take it y, and changing the domain of my function from y to t, okay, as we have been doing previously. So exponential of minus t by 4 and here d of t. Okay, so now integrating it, what I will get here, I will get 1 by 4 multiplied by exponential of minus t by 4 divided by minus 1 by 4. Okay, so these two will cancel out, and here the ranges of it will be from 0 to y. Okay, so now let me write them here, and here it would be minus exponential of minus t over 4, and it will be from 0 to y. Now writing these ranges, what I will get, first writing the higher range here, what I will get, minus exponential of minus y by 4. Okay, and then this range which is 0, so minus exponential of minus 0 by 4. Okay, so now after it I will get what, it will be minus y by 4, and here exponential of 0 is 1, so here I will get minus 1. Okay, or ultimately from it the f of y will be what, rearranging it, this minus will be plus, so I will get here 1 minus exponential of minus y over 4, and that is the CDF of the required function. Okay. So now taking it and putting it here, by putting the value of y equal to 6, what I will get here. So in order to find the value of the probability of y greater than 6, what I can write? I can write here 1 minus f of 6. Okay, because these will be the higher values, and for them I have to subtract the lower values from 1, so that's what I will get. So I will have here 1 minus, here the value of f of 6 would be 1 minus exponential of minus 6 by 4. Okay, so opening this bracket, these two will cancel out, and ultimately I will get exponential of minus 6 by 4 which will be 0.2231. Okay, so that is what, that is the answer of part A of my question, which is around 22.31%, which is not low. Okay, so here I have to consider this value as well, because this is the 22% and which is not low. Okay, so now going to part B of my question, what is the probability that a major repair occurs in the first year? Okay, so here in order to do so, let me move down somehow, and here in order to solve part B of my question, the probability that the year will be less than or equal to 1, and this is what, this would be the f of 1. Okay, so now in order to do so, taking the same function and writing the value of y equal to 1, what I will get, 1 minus exponential of minus 1 divided by 4. Okay, and from it what I will get here, from it I will get 0.2212, which is basically the solution of part B of my question, and this value is not also lower, and this is also around 22.12%, and this is also a very major constraint in the product, because it will also require the major repair within the first year, and the probability of it is around 22%. Okay, so that's it for today, in which we have seen the usability of CDF in the product lifetime and how can we use it for the product lifespan. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.32, and the statement of it is, the proportion of the budget for a certain type of industrial company that is allotted to environmental and pollution control is coming under scrutiny. A data collection project determines that the distribution of these proportions is given by f of y, which is 5 1 minus y raised to the power 4 for the range of 0 to 1 and 0 elsewhere. Okay, so what do we have to do? We have to verify and answer some parts of it which are given in the form of A, B and C. So let us start part A of it, and this is the solution of it. And in solving it, the part A of it is verify that the above is a valid density function, and in order to verify that this is a valid density function, what do we have to do? We must check that whether this converges to 1 or not. Okay, so what do we have to do? I have to integrate it within this range. Okay, so if the answer of it is 1, so which will show me that it is a valid density function. So let me first write it, and it will be from 0 to 1 due to the ranges which are given here, and the function we have here is 5 1 minus 4 to the power 4, and I have to integrate it with respect to y. Okay, so now integrating it, what I will get here, this will be 5 0 1 1 minus y here 4 dy. Okay, so let me integrate it, and integrating it, what I will get here, I will get, it will be 5, and here we will get minus 1 minus y, and here this exponent will be 5 divided by 5, and here the range will be 0 to 1, and here it is, we have. Why this negative? Because we can very easily see that here this y has a negative sign, so integrating it over this one will give me output as minus y as well. So now here these two will cancel out, and integrating it and now putting these values here, what I will get here, I will get minus, so 1 minus y. So now writing the higher range first, so higher range is 1 1 minus 1 5, and then here minus, and this lower range is 1 minus 0. Okay, and this 5. So what will happen? This will become 0. Okay, and this will become 1. So ultimately what I will get here, I will get minus, and this is 0 minus 1. Okay, so which will ultimately give me 1, which shows the validity that this one is basically a valid density function. Okay, so that's what we have, and here we have seen that this is the density function which we had, and integrating it in the range where I had minus 1 minus y whole 5, and it was from 0 to 1. Why I had written it here now again, because I will use it in more cases in our upcoming parts. Okay, so now this is part A. In order to proceed to part B of it, what is the probability that a company chosen at random expends less than 10% of its budget on environmental and pollution controls? Okay, so now this 10% is basically how much? This is basically 0.1. Okay, this 10% is basically 0.1. So I will have a range which is less than the 0.1. So therefore integrating this f of y from 0 to 0.1, which is the higher range, and here writing this f of y dy, this will be what? This will be the probability that the expenditure will be less than what? 0.1. Okay, so now I have to find it out, and previously we have seen that in order to integrate it in the range from 0 to 1, what I have got? I have got this formula, and writing the same formula in the range of 0 and 1, what I can write here? I can write here minus 1 minus y 5, and the ranges here are 0 and 0.1. Okay, so now putting these values here, what I will get here, this minus remains the same, and now writing the higher range, this is 1 minus 0.15. Okay, and also here this minus and 1 minus 0.5. Okay, now simplifying it, what I will get here, it will be minus, and here we will have what? Here we will have 0.9 to the power 5, and here we will have minus 1. Okay, or I can also write it like 1 minus 0.9 raised to the power 5. Okay, now finding it out and finding the answer of it, what I will get here, the answer of it will be 0.4095, and that is basically the solution of part B of my question. Okay, so that is the solution of part B. Now moving to the part C of my question, what is the probability that a company selected at random spends more than 50% of its budget on environmental and pollution control? So here the case is slightly different, and here the case is in which I have to select the budget which is 50% or more than it. So here in order to write it, this 50% is the lower range, which is 0.5. Okay, so now taking this as a lower range, and the maximum range here is 1, and now again taking the same f of y dy, and it will be what? It will be the probability that expenditure is greater than 0.5. Okay, so this is what we have to find it out. Now putting the same equation here by using the different ranges which are here now. So now here I will have minus 1 minus y. Okay, and this is 5, and the lower range here is 0.5, the higher range is 1. Okay, let me simplify it more, and simplifying it some more, what I will get here, it will be minus, and here the higher range is 1 minus 1 5 minus 1 minus 0.55. Okay, so that is what we have. Now simplifying it, what I will have, this will be 0, and this will be 1 minus 0.5 is 0.5 raised to power 5. Okay, and here the answer of it will be 0.03125, which is around 3%, which is slightly smaller than all the previous probabilities. Okay, so this is what we have found out, and that is the solution of part C of my question. So today we have solved the question 3.32 of our book. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.35 of chapter 3, and the statement of it is, suppose it is known from large amounts of historical data that x, the number of cars that arrive at a specific intersection during a 20-second time period, is characterized by the following discrete probability function, which is given by f of x. Okay, and this formula, which is a very well known probability distribution function, which we will discuss in our upcoming videos. Okay, so that is basically characterized by this formula, and on the basis of it we have to solve two parts of this questions, which are A and B. Okay, so in part A of it, find the probability that in a specific 20-second time period more than 8 cars arrive at the intersection. Okay, so this is very interesting part of this question, in which we have to see that what is the probability that more than 8 cars arrive at the intersection. So what is mean by more than 8 cars? It can be 9, 10, 11, 12, 100 and so on as well. So what do I have to find out? I want to find out the probability that the number of cars are greater than 8. Okay, so this is what, this is part A. And how can we do it? This can, you can very easily see that it can be a data which cannot be counted. Okay, innumerable data counts we will have, because more than 8 means all the data points which are greater than 8 are more than 8. So in order to limit ourselves within this range, I can use another trick here, and that is a trick which is there. We have 1 minus probability that x is less than or equal to 8. Okay, so how can I find it out? In the context of the probability, we have known that the total or the overall probability that x is less than or equal to 8 plus the probability that x is greater than 8, this is the overall probabilities, and according to the probability theorems it must be equal to 1. Okay, so the summation of all the probabilities must give us 1, and from it we can very clearly get this formula. Okay, now solving the same probability function and the same part of our question, what we can do here, the probability that x is less than or equal to 8, we can find it out by 1 minus the probability that the number of cars are 0. Okay, plus the probability that the number of cars we have are equal to 1, plus the probability that the number of cars we have equal to 2, and we will add them together until and unless we have the probability that x is equal to 8. Okay, so that is what we will have here. In order to counter it in the context of the mathematics, what I can do here is that if the probability that x is greater than 8, I can use the summation or the sigma function, in which this summation in which x is equal to 0 up to 8. Okay, and here we will have this probability that x is equal to the smaller x. Okay, so we can use this formula. Now we have this formula for this p of x, and that is given here in this form. So now writing it here, what I will get, I will have here 1 minus x equal to 0 up to 8. Okay, and writing this formula, because here luckily we have the same variable which we have here, so we will have here exponential of minus 6, and here 6 raised power x divided by x factorial. Okay, so now let me open the braces here and let me do it here as well. So here doing it, what I will get, 1 minus this exponential minus 6 is a constant value, so leaving it outside this, and here let me have it here from 0, 6 raised power 0 divided by 0 factorial plus 6 1 divided by 1 factorial. Okay, plus 6 square divided by 2 factorial plus 6 cube divided by 3 factorial, okay, unless and until we will add them together up to 8, because this is x is x is equal to 8 and these are values from 0 to 8. So, here I will have 8 factorial. Okay. So, this is what we have. So, now finding them all together and then subtracting it from 1, what I will get? So, I will get here 0.1528, okay, and that is basically the answer of part A of my question. Okay. So, that is the solution of part A. Now, in order to proceed, we have to see that find the probability that only 2 cars arrive. Okay. So, that is part B, and we have to find the probability that x is equal to 2. Okay, only 2 cars arrive, and we can very clearly see that, let me move upward somehow, we can very clearly see here that this is the single occasion here where x is equal to 2, and this is a single case. In order to counter it out, what we can do, we can use the same formula here in which the value of x is now 2. Okay. So, now putting values here, this would be minus 6 and 6 with the power of this x, which is 2. So, this is 6 square divided by x factorial, which is 2 factorial. Okay. So, now finding it out, what I will get here, we will get 0.0446, okay, and that is what, that is basically the answer of part B of my question. Okay. So, that's it for today, in which we have seen the solution of the questions like the number of cars following through a certain point in a certain limit of time. Okay. So, these type of problems are usually solved by the Poisson probability distribution, which we will discuss in our upcoming videos. So, till then, take care of yourself. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So, this is question 3.36 of chapter 3, and the statement of this question is, on a laboratory assignment, if the equipment is working, the density function of the observed outcome x is f of x, which is 2 1 minus x for the range of x greater than 0 and less than 1, and it is 0 otherwise. Okay. So, what do we have to do on the basis of it? We have to answer certain parts of it. So, let me look at the first part of this question, and this is calculation of the probability that x is less than or equal to 1 by 3. Okay. So, by looking at it, I can very easily see that if I will find the CDF for my function here or for my density function here, I can very easily find out this thing. Okay. So, let me first find the CDF for my function here, and in order to find the CDF of it, I know that what I have to do, this would be f of x, okay, that is capital F of x, and what I have to do, I have to take the lowest limit of my function and taking any arbitrary variable here and taking that arbitrary variable as x, because here this x should correspond with this one as well. Okay. So, now taking it and now putting my function here by changing the domain of it. Okay. So, let me change the domain of it from x to t. So, what I will get here, it will be 2 1 minus t, and now integrating it with respect to t. Okay. So, now doing this same procedure as well. So, 2 will be outside and here we will have 0 x, okay, 1 minus t and dt. Okay. So, now doing again 2, and here it will be 0 x 1 dt, okay, and also minus 0 x here t and dt. Okay. Now, integrating them separately and then putting the limits here, what I will get here, I will have here, it will be t and 0 x, and while here I will have t square divided by 2 and 0 to x. Okay. Putting these limits here, what I will get here, I will get 2, okay, and x minus 0 is x. Similarly here, minus 1 by 2, and here I will have x square minus 0 square. So here I will have x square. Okay, so ultimately I will get this one. Okay, so now moving somehow downwards, what I will get, multiplying this 2 inside of it, what I will get, I will have here 2x minus x square. Okay, so this is what, this is the CDF of my function which I have here. Okay, so this is the CDF. In order to simplify it somehow more, what I can do here is that let me add and subtract 1 here. So adding and subtracting 1 here, what I will have, this is f of x, and here I will have minus x square plus 2x. Okay, and here let me subtract 1 and add 1 with it as well. Okay, so now here I will have this function. Now here I can very easily see that this is a function which is the factorization of x minus 1. If I will take this negative sign common here, so here I will have this minus, and here x square minus 2x plus 1. Okay, and here the remaining thing will be plus 1. Okay, so now combining it, and here I will get x minus 1 whole square, and here minus, and here plus 1, or the value of f of x is what, that is 1 minus x minus 1 whole square, and that is what, that is the CDF of my function as well. Okay, so you can use both of them. That is basically the simplified form, because in many books the answer has been written in this form. So in order to do them all is not to confuse them with anything, so that's why I have solved it as well. Okay, so now looking at part A of my question, I have to find the probability that x is less than or equal to 1 by 3, and that is very easily found out by putting f1 by 3. Okay, so now putting the values here, this is f of x, so putting values here, 1 minus x value is 1 by 3 minus 1. Okay, so here it would be 1 minus, this would be minus 2 by 3 whole square. Okay, or 1 minus 4 by 9, or the answer of it will be 5 by 9, and that is what, that is the answer of part A of my question. Okay, you have seen that how easy it is to find the probabilities if I know the CDF of my function. Now similarly, what is the probability that x will exceed 0.5? Okay, so that is the probability that x will be greater than 0.5, and this can be found out very easily if I will make it like probability that x is less than or equal to 0.5. Okay, so this is basically the CDF. I can find it out by using the CDF, which would be what, f of 0.5. Okay, putting all the values here, this is f of x, so it will be 1 minus, here the value is 1 minus 0.5 minus 1 whole square. Okay, so here you can see that, let me move down somehow. Here you can see that by opening the braces, what I will get here, it will be plus 0.5 minus 1 is minus 0.5 whole square. Okay, these two will cancel out, and here the answer of it will be 0.25. Okay, because the square of it will remove this minus sign, and that is basically 1 by 4. So the answer of part B is 1 by 4. Okay, so that is the solution of part B of my question. Now in order to solve part C of my question, here I can see that given that x is greater or equal to 0.5, what is the probability that x will be less than 0.5? Okay, so for it, let me move down again. Okay, so here that is basically the conditional probability, in which I have to find out the probability that x is less than 0.75, given that x is greater or equal to 0.5. Okay, so that is what I have to find out. This is the conditional probability in which this thing has been given, and I have also find it out by using this function here, because previously I have already seen that what was this one. This was basically the probability that x is less than or equal to 0.5, and subtracting it from 1 I have got probability that x is greater than 0.5. So, equivalent is also covered by this one, because this is the continuous probability function, and therefore, this is the same thing. Okay. So, now proceeding towards this one, what I can use here, I can use here the conditional probability, and here in order to do so I will have these two function, and here I will have x is less than 0.75. Okay, and the union of probability that x is greater or equal to 0.5. Okay, and dividing it over what, here dividing it over the given probability, which is probability that x is greater or equal to 0.5. Okay, so I hope this point is now clear. If you have put them together, and that is basically the union. So what is mean by union? Union means it has been combining these two ranges. Okay, so this range and this range, these two ranges has been combined, and therefore these ranges are from 0.5 to 0.75. So therefore in combining them, what I can write here, I can write here the probability that x is greater or equal to 0.5 and less than 0.75. Okay, that is what, that is basically the limit or the limits of this probability, and dividing it over the probability that x is greater or equal to 0.5. Okay, I know I have already known the value of this one, so let me solve the other one as well. So now finding the limits here, I can very easily find this limit by using the CDF, and it would be what, it would be the f 0.75 minus f of 0.5. Okay, and dividing it over the probability that x is greater or equal to 0.5. Okay, so now here we can very easily see that these are the limits. And why did I do it? Because if I have a function here, okay, let me see that this is the CDF and this is a x, and in order to plot them here, what I can see, if I have here this one 0.5 and this one is 0.75. So in order to find this area here, what I can do, I can subtract this area from this one. Okay, so this is what, this is 0.75 and this is f of 0.5. So subtracting from this one, this I will get this area. Okay, which let me identify in this blue color. Okay, so this blue color is basically showing me these ranges. Okay, so I hope you have found out my point. Okay, so now putting values here in the formula for f of x, what I had here, this is the formula which I had. So 1 minus x minus 1 whole square. So let me put these values here, and what I will get here, I will have 1 minus x minus 1. So 0.75 minus 1 whole square. Okay, so this is for this one, and now for the other one I will have, this is minus, and I will have 1 minus 0.5 minus 1 whole square. Okay, so I will have this one, and dividing it over what, here I will have, this was already found out, and that is 1 by 4. Okay, so now let me solve them together. 1 minus 0.75 minus 1 is minus 0.25 whole square, and also here minus 1 and plus Here 0.5 minus 1 is minus 0.5 whole square, okay, and dividing it over 1 by 4, okay. So these two will cancel out, and at the end I will have here this minus minus will be plus, this minus minus will be plus 0.5 whole square minus 0.25 whole square divided by 1 by 4, and that is 0.25, okay. Solving it out, what I will get here, ultimately I will get 0.75, okay. So which is basically 3 by 4, okay. So the answer of part C of my question is 3 by 4, but the only thing here you have to remember is this formula, that how we found out this formula, and that is due to the conventional formula of the conditional probability, okay. So that's it for today, in which we have seen some important points related to the conditional probability and the usage of the CDF. If you have any question, you can ask me in the comment box. See you soon. Welcome guys, I hope all of you will be fine. So this is question 3.37 of chapter 3, and the statement of this question is determine the values of C so that the following function represent joint probability distribution, okay. So you have to keep in your mind that joint probability distribution basically takes two variables, and that is basically the joint probability distribution of the two variables, okay. So of the random variables x and y, so you can see here that here we have been mentioning two variables which are capital X and capital Y, okay. So on the basis of it, we have to solve two parts of our question, and the part A of our question is fxy is equal to cxy for x equal to 1 2 3 and y equal to 1 2 3 as well, okay. So let me solve the part A first, okay. This is the solution, and part A is what, that is fxy is equal to cxy for x equal to 1 2 3 and y equal to 1 2 3, and if this is a valid joint probability distribution, we have to keep in our mind that all the values here when summed together, it will give me what, it will give me 1, okay. So what will happen here, this will be summed with respect to x and also will be summed with respect to y, and when this function will be summed together, it will give me 1, okay. You have to keep in your mind if this is a valid joint distribution function, and it as it is given, so that is basically the joint distribution function which is valid, okay. So we have to use this condition here, and all the values given for x and y are here. These are 1 2 3 and 1 2 3 as well. So we have to take each value of x and multiply it with the other value of y, similarly then add them together because of the additions here, and similarly for the other values of y as well. So let me do it here as well, and here taking this c out of here, what will we get, because c is a constant, what will we get? So taking all values of x which are here 1, so let me use this 1, multiply it with the all values of y which are also here, so 1 multiplied by 1, okay. Similarly plus 1 multiplied by 2, this is the value of x multiplied by the value of y, plus because these are summed together here, and also 1 multiplied by 3, this is for the first value which is 1 for x and all the values of y. Similarly now taking the second value of x which is 2 and multiplying it with all the values of y which are 2 multiplied by 1, and then the second value 2 multiplied by 2, okay, and the third, that is 2 multiplied by 3, okay. And now the last one here is 3, so taking this 3 multiplied by 1 plus 3 multiplied by 2 plus 3 multiplied by 3, okay. So here it is, and it is here as well, and that is equal to 1, okay. Now taking all these values, as these have been added together, so let me take them and multiply and add them. So 1 1 is 1, this is 2, this is 3, okay. Now here this is plus 2, this is plus 4, okay, this is plus 6, okay, this is now 3, this is 6, and this is 9, and that is equal to 1. Okay. So now in order to find the value of C, let me add them together. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 10 is 18, 18 plus 3 is 21, 6 27, uh, 21 27, and 9 is 36. Okay. So now we have here this equal to 36. So 36 multiplied by C equal to 1, and taking this C equal to what? This would be 1 over 36, and that is the value of the C here which we wanted to find out. Okay. So that is the solution of part A of our question, in which we have determined the value of C here. Okay. So now moving towards part B of our question, here we can see that this is basically a joint probability distribution function for all the values of x and y which are here, and taking the same steps here. This is for x, this is for y, and the function we have here is x minus y, that must be equal to 1 in case of the joint probability distribution function. We can see here that all the values of x or y are given here. Now taking this first value of x and making it the combination with all the values of y, and so on so forth, because we have here all these values, and then also adding them together as well. Okay. So let us start here. So C will be moved out of these operations because this is a constant, and here if x is 1, so it will be, sorry, if x is minus 2, so it will be what? Minus 2, and the other one is minus, so minus minus 2 will be what? This will be plus 2. Okay. So here we will have it plus, the second one is minus 2, and this one is 3, so minus 2, and here we will have it minus 3. Okay. Similarly, now we have the second value here of x, that is 0, so 0 plus 2 here we will have. Okay. Because minus minus is plus, and also the 0 0 minus 3. Okay. Similarly, sorry, that is also the addition. Similarly, the last one here is 2, 2 minus 2 is 2 plus 2. Okay. And also here we will have 2 minus 3 we will have it. Okay. So these are all the values which are we have, and these are equal to 1. Let them all together and get the values which we have. So minus 2 plus 2 is 0, and the absolute value of it is also 0, because this absolute is basically giving me the positive values of all or whatever we have inside of these absolute signs. Okay. So now here minus 2 minus 3, this is minus 5, which is basically 5. Okay. And this is now 2. Okay. This will be plus 3. Okay. This will be plus 4, and the last one here is will be plus 1, that is equal to 1. Okay. So now then adding them together, 5 plus 5 is 10, and this 5 is 15, so 15 multiplied by C, that is equal to 1, which will ultimately give me what? The value of C will be equal to 1 over 15. Okay. So that is what? That is the solution of part B of our question. Okay. So that's it for today, in which we have seen the progression of the joint probability distributions. What are the joint probability distributions, and how can we find out different values out of them if the condition of the joint probability distribution has to be satisfied. So that's it for today. See you soon. Welcome guys, I hope all of you will be fine. So this is question 3.38 of chapter 3, and the statement of it is, if the joint probability distribution of x and y is given by f of xy is equal to x plus y divided by 30 for the values of x which ranges from 0 to 3, and for y which ranges from 0 to 2. Okay. So on the basis of it, we have to find some probabilities which are basically the joint probabilities. So before going into each part of this question, let us first draw a table for the values which are given here. So in order to do so, let me write here different values for x and y. Okay, let me have here, this is, let me call it x, and here we have y. Okay, so writing all values of x and y, what we will have, let me use this color. For x I have 0, 1, 2 and 3, so it is 0, 1, 2 and 3. Okay, these are the values for x, and for y we have what, 0, 1, 2, so we have here 0, 1 and 2. Okay, so these are different values of x and y. Now on the basis of the formula, which is x plus y divided by 30, what we can find out, we can write these values of x and y in this, and we can write their values. Okay, so here the value of f00 will be what, writing the value of x 0, y 0, what I will get, 0 plus 0 divided by 30, so it will be what, it will be, let me use another color for it, and this is this one. Okay, so 0, 0, this will be 0. Okay, similarly 0 plus 1 divided by 30, this will be 1 by 30. Okay, and here 0 plus 2 divided by 30, this would be 2 divided by 30. Okay, so these are all the values for x equal to 0, while all the values for y, which are 0, 1, 2. Similarly, for x equal to 1 and y equal to 0, this would be 1 plus 0 divided by 30. So, this would be 1 by 30. Similarly, here it will be 2 by 30. Okay, and here we will have 3 by 30. Okay, you know why? Because putting value of x here, okay, which are on the vertical axis and on the horizontal, we have the values of y, putting it here, and using this formula we can find out these probabilities. Okay, similarly here we will have 2 by 30, okay, 3 by 30, and here we will have 4 by 30 for this x equal to 2, and for x equal to 3 we will have 3 by 30, 4 by 30. Okay, and here we will have 5 by 30. Okay, so these are different values of the formula f, x and y for all the values of x and y. Okay, so now on the basis of it, we are asked to find out some probabilities, which are probability of x is less than or equal to 2, such that y is equal to 1. So this is part A, and in part A we have to find out the value of x is less than or equal to 2 and y is equal to 1. Okay, so here let me see that where is it that y is equal to 1. So this is here, this is the overall column where y is equal to 1. Okay, similarly on the basis of it, we have to see another condition here, and that is x is less than or equal to 2. So it will start from where, these will be from here. Okay, you can see that it will be from here to here. So these would all be the values where x is less than or equal to 2. Okay, we can see that this is the range. So 1 by 30, 2 by 30, 3 by 30. Okay, so these are all the values. So let me write them here. Okay, so here I will have 1 by 30 plus 2 by 30 plus 3 by 30, and these are the values where we have f is where x is 0, okay, and y is 1. This value is f is x is 1 and y is 1, and for this value we can see that here x is what, x is 2 while y is 1. Okay, so we can see that these conditions has been fulfilled here. So using it here, the LCM, this would be 30, and here it would be 1 plus 2 plus 3. Okay, so 6 by 30 or 1 by 5. Okay, so that is what, that is the answer of part A of our question. Okay, so this is the answer of part A. Now moving towards part B of our question. which is word probability that x is greater than 2, okay, and y is less than or equal to 1, okay. So this is another condition. Now let me see that where this condition occurs. So y is less than or equal to 1. So these are basically all these values which we have here. These are for the values that y is less than or equal to 1. So now looking at another condition here, and that is x is greater than 2. So x is greater than 2 is 3. So therefore only this condition will satisfy, because here y is less than or equal to 1, and here we have x is greater than 2, which is 3. So now these condition will be satisfied, okay. So writing these values here, now let me write these values here. So I will get here 3 by 30 plus 4 by 30, because these are the values we have here, and here ultimately we will get 7 by 30, which is basically the answer of part B of my question, okay. So this is part B. Now moving to part C of my question, let me solve it here, and that is probability that x is greater than y, okay. So now let me write all the combinations where the value of x is greater than y. So it will be f 1 0, okay. Similarly we can have here f 2 0, okay, and f 2 1. This is again the condition where the value of x is greater than y. Similarly the other one is f 3 1, okay, sorry, f 3 0 plus f 3 1 plus f 3 2, okay. So now looking at all these values which are here, so f 1 0 is how much? That is 1 by 30, okay, it would be 1 by 30. Similarly f20 is how much? F20 is 2 by 30, it would be 2 by 30. F21 is 3 by 30, okay. F30 is again 3 by 30, okay. F31 is 4 by 30, and the last one is F32, which is 5 by 30, okay. Adding them all together, and ultimately we will get what it would be 18 by 30, okay. We can see that 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 8 is 18. So here we will get 3 by 5, which is the answer of part C of my question, okay. So this is the answer of part C of my question. Now moving somehow downwards and looking at the solution of part D of my question. And what is part D? We have to find out the probability that x plus y is equal to 4, okay. So here, in order to see that where does this x and y is equal to 4, let me again write the function where x and y are equal to 4, and here we can have here this 2 2, okay, and also this plus is for or, and also we can have here 3 1, okay. So these are the only two possibilities here where x and y when added together will give me 4, okay. So now writing their values, I will get here this is 4 by 30, f22 is, okay, you can see that this is 4 by 30, and also f31, which is here, sorry, which is here, and that is again 4 by 30, okay. So it will be 8 by 30, which will ultimately give me 4 by 15, and that is basically the solution of part D of my question, okay. So that's it for today, in which we have seen the solution of question 3.38 and all the parts of this question. If you have any question, you can ask me in the comment box, because all of these things are related to the two variables, and that is the joint probability distribution function. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.39, and the statement of it is, from a sack of fruit containing 3 oranges, 2 apples and 3 bananas, a random sample of 4 pieces of fruit is selected. Okay, so in the given data we can write here that we have here 3 oranges. Okay, the number of oranges are 3, 2 apples, okay, and also 3 bananas. Okay, so from them I have to select what? I have to select 4 pieces of fruit randomly. If x is the number of oranges, so oranges are represented with x, and y is the number of apple, so this is y, this is x. Okay, so what do we have to do? We have to find the joint probability distribution of x and y, which is part A of our question. Okay, so this is what, from them I have to select 4 pieces of fruit randomly. Okay, so the part A of our question is here. Okay, and we can see very clearly here that we have the total number of fruits here. The total number of items of fruits are 8, which are 3 plus 2 plus 3, which are 8, and from 8 I have to select 4. So the total selections are basically, from 8 I have to select 4. Okay, when I will do it like 8 factorial divided by 8 minus 4, that is 4 factorial, and then 4 factorial, this would be 70. Okay, so I have to select 70 item, and these are the total 70 selections which can be carried out in total. Okay, so in order to find the joint probability distribution of x and y, initially we have the 3 oranges, and out of 3 oranges I have to select, let me have here small x, and I have to select x items. Okay, similarly, if I have the apples, which are basically 2 in number, and I have to select y number of items from them. Okay, and the remaining items are banana. Okay, so the number of banana here are 3, and from them I have to select how much those would be the remaining one from the 4, because the total number of items here would be 4. So therefore I have to see that how many x and y are, and the remaining items which are out of 4, I have to select them. Okay, so these would be the selected items which will comply with the condition of our question. Okay, so I hope you have understood, and dividing it over the total number of selections which have been already calculated, and these are 70. Okay, so these are what? These would be f of x, y. Okay, and this is what, this is the joint probability distribution for part A of our question. Okay, so here also what can be the values of x and y? So the values of x can be, small x can be, these are the total number of oranges, so it can be no orange, or 1 orange, 2 orange, or 3 oranges. Okay, similarly y is how much? That can be 0, 1, or 2. Okay, and also the total number of items here can be greater or equal to 1 and less than or equal to 4. So this is basically the condition for the formula which we have derived here, and that is what we have found out here for the joint probability distribution of our part A. Okay, similarly in part B we are asked that if P of x y is a member of A, where A is the region that is given by x y such that x plus y is less than or equal to 2. Okay, so here in part B we have to see that what are the items for which we have to find the probability of x y such that x plus y is less than or equal to 2. Okay, so which items can it be? So those can be found out from this formula, and these can be here, either it can be 0 1, and we can see that 0 plus 1 is 1, which is less than 2. Okay, also it can be plus f 0 2, so 0 plus 2 is also less than or equal to 2, which lies in between this range. Okay, similarly f of 1 0, okay, plus f of 2 0, okay, and also f of 1 1. Okay, so these are some items which are the values of x and y which I have to put here, and after finding the values I can add them together. Here you should also note that I am not using here f of 0 0. Why? Because if I will add here f 0 0, so these two items will be 0 0, while this one only be selected, which cannot fulfill our requirement that the total items here should be 4. Okay, because the total number of items which are 3, and these are the 3 bananas, which will not satisfy the condition in part A. So that's why I'm not selecting this f of 0 0. Okay, so now finding the values of these items and then adding them together, what are those values? So let me first find out f of 0 1. So for f of 0 1, the formula here is this one. So let me move upward somehow. So this is the formula, and putting the values of x and y. So x is 0 here, okay, y is 1 here, and also it would be 3, x plus y is 1, and 4 minus 1 is 3. Okay, so it would be this one, and it will be what? It will be 70. Okay, so now finding them out, what I will get from here? I will get 1, from here I will get 2, and from here I will get 1, and so ultimately it will be 70. So it will be 2 by 70. Okay, also if I will do it for f of 1 0, what it will be? It will be 3 1, okay, it will be 2 0, and here it will be what? It will again be 3 3 divided by 70. Okay, so now finding them out, what I will get? It will be 3 factorial divided by 2 factorial into 1 factorial. So these two will cancel out, and at the end what I will get here? I will get 3. Okay, so 3 will be left here. From it I will get 1, and from it I will again get 1. So it will be 70. So I will have 3 by 70. Okay, also the other values are, let me find the other values, which are f11, f20, and f02. Okay, you can find them out just by putting these values into this formula. Okay, you can see by putting these values in this formula, and then ultimately you will use this formula for adding them all together, which are the values, just like f01 is here, f02 is here, and also this one is here as well. Adding them all together, and ultimately what you will get here, the answer of part B will be 1 by 2, and that is the solution of part B of our question. Okay, so that's it for today, in which we have seen that how to find the joint probability distribution of any items which are given to us. If you have any question regarding this exercise problem, you can ask me in the comment box. See you soon.